Example 2 states, for the first 15 months after the introduction of a new video game, the total sales can be modeled by the curve S of t, which equals 20 e to the 0.4 t power units sold, where t is the time in months since the game was introduced. Part A asks, what are the total sales after 10 months? Total sales. We just want a total, so we just want to use the S to t function, where since we're solving for 10 months, we'll go ahead and plug a 10 in, get our calculator out, and we want to round to the nearest whole number. It's not in the directions, it should have been. But since that 1 is followed by a 9, our answer will be 1,092. And we did units sold, right? It asked for sales. We were just using the S function, and the S is measured in units sold. So I just took that right off of the question. Part B. At what rate are the sales changing after 10 months? So we're asking rate sales are changing in 10 months. So we have the rate of change piece, which we know means we need a derivative, and sales means we're taking the derivative of the S function about the variable t, and t is months. T is the input function. So I need to take the derivative, focusing on the 20 just being a lead coefficient, and the derivative of e to the 0.4 t is an exponential derivative, so copy the question, natural log of the base, or maybe you knew that was 1, so you don't write it, derivative of the top, and then cleaning this up. So the natural log of e was 1. I can multiply the 20 and the 0.4, so that the derivative is 8e to the 0.4 t power. But don't forget, we're solving this one for 10 months. So I need to take that derivative where I plug a 10 in. So I have to plug the 10 where the t goes in the exponent, and I get 436.785. Again, we'll round to the nearest whole number. Since the 6 is followed by a 7, which is 5 or larger, that 6 will round up to a 7 to give me 437. Okay, now think about the units. We're asked for sales, and when we did sales before, it was measured in units sold. So I need to do units sold, but what did we take the derivative of? We took the derivative of t, which was the time in months, so our derivative is per month. You guys should actually be pros at that by now. Part C. At what rate is the growth rate changing after 10 months? So there's a lot of similarity to the question above, except for it's asking for growth rate. So that means that we want the second derivative, because they're not asking for the rate of change of the sales function. They're asking the growth rate. The growth rate was that derivative we just had. So we need to take the derivative of 8 e to the power 0.4 t. So the 8 is our lead coefficient. Exponential as we copy the question, natural log of the base if you write it, derivative of the top. We're going to multiply the 8 and the 0.4. The natural log of e is going to kind of multiply to 1 and drop out. So my second derivative is 3.2 e to the power of 0.4 t. And again, I'm ready to solve this one for 10 months, which means I'm going to plug 10 months into this derivative. Get out my calculator. Round to the nearest whole number. The 4 is followed by a 7, so I'll get 175. Now focus on the way we solved the last problem. When we wrote the beginning of the derivative, what we did is we looked up to the answer we had above, right? We're taking the derivative of the growth rate. The units on the growth rate are units sold per month. So I need to start with units sold per month. But now that I've taken the derivative of this thing, what did I take the derivative of? T, which was time in months. So again, just like on the problem above, when I did per month, I need to do per month of the thing I took a derivative of. I took a second derivative. When we have something like this, where we've got per twice in a sentence, we actually tend to write the answer as 175 units sold per square month. I mean, I wrote the square month symbol.